Hello everyone, welcome to Solid Edge University and this session covering Solid Edge Cam Pro 2023. My name is John Vincent. If you don't know me, I'm one of the CAM application engineers here at Swoosh Technologies. I've been a long time Siemens user, both from the Solid Edge line and the NX line of the softwares, but primarily always focused on manufacturing. So today in this session, we're going to go ahead and cover a number of new features and functionalities inside of Solid Edge Cam Pro. Siemens has given us some new operation types, some new features and functionalities inside of the software that, of course, through conversations with customers and the process of asking for enhancements, a lot of these features and functions have made their way into the software based on those processes. So we always appreciate that kind of feedback from the software end users to really understand what's involved or what issues are you facing on a day-to-day basis in your operations. So let's go ahead and dive in. We'll take a look at some of these. I have a slide deck here that'll speak to some of these operations, and other ones I'll go ahead and actually jump into Cam Pro and do a little bit of demonstration. So the first point we want to talk about today is 3D adaptive roughing. So Cam Pro, we've had an adaptive roughing operation for quite some time now, probably going back to NX 12-ish time frame. And that's when Siemens transitioned from tricordal milling operations to adaptive tool paths, where it's more utilizing chip thing technology, but more efficient than kind of traditional tricordal milling. So some of the benefits you'll see here with the new 3D adaptive roughing operation. First of all, improved toolpath generation performance. The operation just works faster, which is a welcome addition from anybody. The reliability and how efficient dynamic holder collision and avoidance works. Again, that speaks to the reduction of time it takes to generate a toolpath. The stock model, so kind of working with IPW, is just a lot more efficient and accurate than in the previous operations. We've also had the addition of some concepts that we didn't really have inside of our previous adaptive operation. Just changing the way that we can handle some thin wall machining areas, a little bit enhancements in the bottom up cutting settings. And one of my favorite things is what's called flat face top off. So this is, I'll kind of jump into Cam Pro here in a moment, but this is a great way to not have to utilize bottom up cutting just to get the various faces and heights of your geometry milled in this type of an operation. So I'm going to do that. I'm going to go ahead and jump into Cam Pro right away. And let's see here, I'll jump into one of my sample parts. And in this case, we have a mold cavity that we can look at applying an adaptive operation to. So I'll go ahead and create a new operation. And I'll select our 3D adaptive roughing. And I'll go ahead and pick a tool. Yeah, a 12mm tool, that'll be just fine for us. And I'll go ahead and say OK and initialize this operation. So you might notice that the dialog is a little bit lighter than the previous operation, just in terms of number of settings and the way that we specify things like cut levels. The prior variant of this operation very much had a look and feel of the cavity mill operation. Well, this has been kind of done away with. This is a new ground-up operation, and you'll see there is no cut levels. I think that's pretty noteworthy. But what we do have is our range type. So we can use our automatic range type, and I don't want to change any settings just yet. I want to kind of show what some out-of-the-box options give us, and then how we can modify them for the settings for our uses. But you'll see that the range type is set to automatic. This is just going to go ahead and look at your IPW and understand what material still exists and go ahead and target those regions. But maybe we want a little bit more control over there, and that's when we can go ahead and go to the specify option to choose kind of our starting planes and top plane or ceiling plane and floor planes. Range definition, just setting your cut levels. This top off flat faces option. This is this little tooltip flyout gives a good depiction here. That by default with top off flat faces on, we're always going to target those intermediate faces, planar faces, to make sure that we cut all the geometry that's really available to us without having to go to the extreme of setting bottom up cutting and playing with our minimum cut settings and step up values to get the tool paths that we want. So I'm going to go ahead and generate. So again, this is just an out-of-the-box operation, and I'll go ahead and generate this. And we can see that our toolpath creation, if you were watching the status line here, kind of got up to our 74% value pretty quickly. And let me display my toolpaths. We'll be able to see that, we have our toolpath generated. In this case, we're looking at, based on our depth of cut, we're also topping off, as we said, our flat faces. So now maybe I want to take a look at kind of limiting some of these settings, just to give an understanding of what this looks like. But before I do that, I will go ahead and we can look at displaying our IPW and really understanding what this toolpath is doing, how it's processing this. So you can see we're utilizing the full depth or length of our flute before doing any of the top faces. So it's a nice, very efficient cut. Again, the old adaptive operations, we'd have to play with our settings to do bottom-up cutting to be able to achieve cutting in these various areas. So really, the new 3D adaptive operation just gives us what we likely want right out of the gate. You can see here we're topping off some of these other areas, and now up to the top face for the entire part. All right, so let's take a look and see if we wanted to go ahead and change some of these settings. I could specify some different regions. And you can see I can enter in numeric values, or I can pick geometry on my part. So maybe I want to limit myself to only really cut between the top surface and the kind of low tangent point here of the actual cavity of this particular mold, or this particular part. Again, you can see how quickly we were able to generate our toolpath there. And let's see. So this is an interesting result. You see, because I picked this very low point, the tool can't fit into this cavity. So it's going to omit that altogether. So this is where you may want to come in and put some numeric values in here. Maybe you can see here with the negative 24 value, we can go ahead and achieve the toolpath that we likely would want. Okay, so maybe we don't want to play with these numeric values. This is where we can still use our bottom-up cutting to go ahead, and I'll leave the default values. We'll just go ahead and generate those and still cut the regions as you may expect. So you can note just how quick these toolpaths are now generated. So with the bottom-up cutting turned on, we're able to walk all the way up these walls as one might expect. All right, face mill mid pass, great new operation. This is the first release of this operation in this 2023 Cam Pro. Talking with Siemens developers, there's a lot of room for this operation to grow, but I'll tell you that it's really beneficial. I'll show you here in just a moment. For any time you're looking to face mill one piece of geometry, so like in this case, this is a great example that we have a face, it's got a bolt pattern on it. With a typical floor wall operation or floor without wall operation, you would likely have to play around with a number of settings to get a nice reliable toolpath that you would like to see. But now with this operation, it's intended for these kind of single pass face milling operations. And essentially we just have two patterns. We have our mid pass pattern, which is typically intended for an open region cut, or the convex hull pattern, which is intended for closed region geometry. Currently, you can only select one face. That's an important caveat. This is something that further development will kind of expand. But this operation does support the use of end mills, any bull mills, so end mills with corner radiuses, or chamfer mills, which is typically how a face mill is defined inside of CAM Pro. So let's just take a quick look at this. I'm going to go ahead and let's turn our blank geometry off here. There we go. And if I just want to face this top geometry, I'm going to go ahead and create a new operation. And you'll see the first selection is our face mill mid-pass. And in this case, we have a 25 millimeter diameter tool that I'll use for this operation. And simply just by specifying the cut area and saying OK, I'll leave the mid-pass option. I can choose to generate, and we can see that we get a nice single pass going down the middle of this geometry. And there's very few options here. You see that we're kind of engaging from the inside of this geometry. Let's go ahead and reverse the direction of this toolpath. All right, our engages are happening on the exterior portion. If I just go ahead and take a look at this, we're cutting kind of right on the center of the tool. Maybe we want a little bit of an offset here. So let's go ahead and offset our pattern. You can see that I'm already getting a preview, this dark blue line, of what my 3 millimeter offset will be. Let's go ahead and generate that. And the toolpath is offset. So we can offset to utilize better chip thinning strategies in our facing operations. Really user-friendly operation here. Let's just take one last quick little look here. And I picked this ID face now. Let's do the convex hull option. Set our pattern offset back. And we'll go ahead and generate. Ooh, I have my reverse direction on. Let's turn that off. And here we can see that we are coming in and cutting the interior portion of this part. You can see I'm getting a little bit of faceting going on here. Let's make sure we're all the way open. Looks fine. All right. So again, we can come in and specify standard things like floor stock values, again, pattern offsets, come into your non-cutting moves, and do all the certain aspects, settings that you would expect in an operation like this. Guiding curve medial axis. So if you're a user of the guiding curve operation, again, whether this is the variable axis or the fixed axis variant, you know that you always have to specify guide curves. So guide curves can be geometry from the part itself, whether it's edges of geometry, faces, sketches, curves that exist in the part, and they can lie, and typically it's best recommended that they lie within the cut geometry, but that's not a requirement. We now have two additional pattern types, morph around mid-pass and offset around mid-pass. And what this does is NX will derive a curve going down the middle of your cut area to use as your guide curve. So you don't even have to specify any curves, just your cut area. So again, I'll just do a brief example on this. Let's jump back to this mold we have. And if I go ahead and create a new operation, and I'll just do a fixed axis guiding curve, grab ourselves a ball mill, and we'll look just at the label area. It's kind of the center section of this mold. So yes, with our morphing option, I could pick a couple sets of curves here. Again, if I display what my cut area is, it's just the center section. So I could pick a curve on the right-hand side, left-hand side, and morph between those. But if I choose to just go ahead and morph around our mid-pass, I'll do a zigzag option, and I can go ahead and generate this toolpath right away. And we'll see here quickly that we get a nice toolpath that's doing a zigzag cut around the middle of this geometry. So I didn't have to go and specify that geometry. And this is a pretty simplistic selection of geometry here, but this works in a lot of great scenarios. So something that I would really suggest users out there, if you're using guiding curves, or even if you're not using guiding curves, maybe getting into picking guide curves and things like that was a little intimidating for you. Great new option to be able to program using this operation, really high quality toolpaths. You have the ability to come in and specify point distributions, and depending on what your requirements are, guiding curves is really my go-to operation for semi-finishing and finishing operations when I'm doing any kind of contouring. All right, that brings us up to turn mill. So this is a new turn mill operation. It's part of the rotary category of operations inside of Solid Edge Cam Pro. And this is intended to use a milling tool while cutting in a rotary motion. So this is going to be common on, say, like a 4-axis machine. Maybe you have a 3-axis vertical with a 4th axis rotary mounted on there, or a mill turn machine. Again, is really kind of like the core functionality of this. But it's going to be beneficial in parts where you have offset cylindrical surfaces that are not along the center line, so you're not going to be able to necessarily use a turning tool to cut them in a traditional sense. And you can go ahead and use this new turn mill operation. So let's take a look at this one. We have a part. Again, you'll see that we have a cylindrical surface here that's offset from the center of our part, center line. And the great thing here, and this is kind of a common theme, is just how easy it is to program these new operations. That's a big takeaway. That's, I think, a big focus that I want to really stress, that Siemens is investing a lot of time and effort into these new operations, not just to give you the capabilities that are being asked for, but to make the ease of use really, really powerful and easy, where you don't have to have 10, 15 years of experience using the tools to be efficient with these cut patterns. So I'm going to go ahead and just choose an end mill and set my geometry and method views. And again, we have a very simplistic looking dialog. The first setting here is axis of rotation. So it's asking me, am I rotating around X, Y, Z, anything like that? Let's just leave it at Z for right now. I kind of want to point something out here in a moment. So by default, our geometry is going to be looking at the entire part. You see that my whole part is highlighted here. And I'm specifying that I'm going to rotate around my Z-axis, and I have the options to limit my machining range. I can do this in an axial manner, radial manner, or axial and radial. So in this case, let me just specify some axial containment. Again, these dialogues where you can specify numeric values or pick geometry on your part are kind of familiar across a number of different operations now. And ultimately what this gives me is I'm specifying that I only want to cut between these two faces. So let's go ahead and generate this. Okay, really quick. that was real time. We can see that we're getting our tool path. And if I go ahead and display this IPW and replay this tool path, we can see that we're cutting this in a cylindrical manner. But you can note that we're cutting evenly on each side. So that means we're cutting directly along the center of rotation right now, which really is not what we want in this case. It may be, you may want to do something like this first, and then come back and with a secondary operation, cut the offset portion. But the reason I wanted to point this out is to show that in the turn milling, just because I have my axis of rotation at ZM, I don't have to rotate around essentially my 0 point. I want to come in and specify my axis and my point. So essentially, I want to rotate around this point. Now when I go ahead, and I'm going to leave all my limiting geometries here as they are, I can generate this. And now we're going to see we have a tool path that is really cutting along this geometry a little bit more effectively. Let me go ahead and just change my depth of cut so we don't have quite so many tool paths here. Okay. So now if I want to go ahead and let's simulate this. Maybe I'll turn my machine back on so we can view this a little bit better. So here we are in our machine tool simulation. And let's go ahead and get this started. And we'll go to our tool changer, get our tool. And we can see that we're approaching our part. And now, really following that offset value, you can see how we're cutting in a cylindrical motion, but offset turn milling here. So you can see that we're engaging only in portions of the geometry right now. So let's specify or speed this up a little bit. You can see we're honoring those settings, trimming along the axial containment that I specified. So again, a fairly complex toolpath or scenario that certainly you could have done with other operation types, but there would have been a lot more work involved into picking cut areas and maybe drive surfaces or drive curves, specifying offsets, number of passes and stock offsets. So the ease of use here is really what we want to stress. All right. And the last thing that is really beneficial is tool contact shift. If you've done any kind of turn milling type work or cutting of cylindrical surfaces with end mills, kind of this lead value of the tool is quite critical. And there's some calculators out there to calculate, okay, what is my true lead angle to cut in a certain region? Well, now I can just enter a value. I want to offset by this 10 millimeter tool. I could put in a value. I could say, I want to offset by 40% of my tool value and go ahead and generate this tool path. And now as I step in, we'll see that. Let's go ahead and play that a little bit faster. You can see that we are truly cutting with this leading edge, which is oftentimes what you want to do in this type of an operation. So really simplistic on using these functionalities. All right, check toolpath. So if you've been a Cam Pro user, or even in the earlier days when it was NX Cam Express, things like that, you'll know that there was always a function called gouge check. And you could go ahead and launch that and check against to make sure your tool wasn't gouging into your part or your holder wasn't colliding into your part. Well, that functionality has really been enhanced, and it's now called tool path check. And we have the ability to check for gouges, check for collisions of our tool and our holder against our part, as well as checking collisions of our tool and our holder against our IPW. This is a big benefit here. Without having to get into the full-blown simulation, you can use the check toolpath functionality for checking against your IPW. So we'll just take a quick look just to see what this check toolpath looks like. So I can simply just pick an operation and choose check toolpath, and I can specify, do I want to check all these criterias? And do I want to check against my tool parameters? So if you're using parametric-based tooling, which most users are, so you're specifying your cutting tool, shanks, holders, all inside of NX. But if you are using solid assembly, so NX graphic files or SE Cam Pro graphics files, maybe you want to check against the actual 3D model of from a machine tool vendor or a tooling vendor, you can choose solid assembly. And we can run the check here, and we get a report in the end. In my case, I don't have any findings of any gouges, anything like that, in this particular example. But you would show all your findings here to really understand If there are any collisions, where is that occurring? And then you have the ability to go and resolve those issues. Okay, that brings us to FBM configurator. FBM is feature-based machining. I'm not going to dive into this one too much because this is really a pretty big topic. But what's noteworthy here is if you are experienced with feature-based machining, or at least if you just know what it is, there was a standalone application to go ahead and modify any of your rules or logic for finding features or for creating feature processes. So essentially automating your toolpath creation. That was the machining knowledge editor. So now we have FBM configurator. Really has the same look and feel to it in terms of the structure, but it's a little bit more modern interface. But important is that it is now embedded inside of NX. So you can launch this, from Cam Pro. You can launch this at any point in time from your Cam Pro interface. Again, if I would just come down to my tools here, I would be able to... It's not launched on my tools library for whatever reason. So I just went ahead and searched for my FBM configurator, and now we can see that I have my FBM configurator launched from within SE Cam Pro. And so here's all of our machining knowledge features. Like I said, I'm not going to get into this. These are our machining knowledge rules, feature recognition rules that come out of the box. So you have some functionality out of the box. But if you want to get into this and start creating your own rules, you can certainly do so with the appropriate licensing. Machine tab. If you are a user of simulation kits, you can now very easily retrieve machine kits from the machine library, browse for machines on Post Hub, import to the library, export, all these different things, and we have a dedicated tab for that now. So again, if I'm in any manufacturing file here, I can go to my machine tab, and I have a number of different options available to me. Again, if I want to open a machine assembly for the kit that I'm currently working on, it jumps right into that assembly. Maybe I'm building a simulation kit and I realize I need to change some of my settings in Machine Tool Builder. I don't have to go through and manually navigate to this location anymore. I can just go ahead and navigate right to it via that dialog. By the same token, I can import machines to libraries, retrieve them from the library, or even jump over to Post Hub to search for other kits that might be required. Here you'll log in with your WebKey account information. So then the next step, whenever you do load a sim kit into your environment, we now have some enhanced settings here. The big thing is that we can change our machine translucency, change some layer options. Just makes it easier for displaying this part mounting process. I will show that briefly here. In this case, I do have a machine loaded right now. Let me turn it on so I can kind of demonstrate. So I have a machine loaded. If I wanted to replace this machine, I can come to, in my operation navigator, I want to retrieve a machine from library. Maybe I would like to use my new machine tab and just jump right to it instead of going through the operation navigator. And I can go ahead and pick some other machine tool that may be appropriate for me. And once I make that selection, you can see the default option is now to have the machine being shown as translucent. Prior, you wouldn't see the machine, you would just be picking a point here. So you wouldn't really be able to kind of work in context here to understand what are you really doing. You'd have to know that machine, know the orientation. So now we're able to show this preview. And of course, dynamically we can change and move our machine position around. Maybe we don't want to orient the part on the machine this way. We want to change this by 90 degrees or whatever the scenario might be, but we can see that all during our process of loading that machine tool. Operation edit prediction. So this is a little bit of a learning behavior that SECAM Pro has now. That as you go through and change some of your settings inside of a given operation, Cam Pro is really learning what settings do you change oftentimes. And as you start changing, in this case, we see where we have a floor facing without wall operation, it's going to start learning what settings do I change and include those on this new node called prediction. So if you install a new version of the software and you open up an operation, a prediction node will not exist until you start making changes inside of those operations. And then it's learning and it'll place, I believe it's 10, up to 10 settings on this prediction node. And I can show that quickly here. Let's go into one of our existing operations here. So if I look at my 3D adaptive roughing, I did come in here and change some settings. So you'll see there is now a prediction node that, yeah, I changed my range types, changed some of my cut level settings. So those have been added in this prediction node, or they're made visible in this prediction node. So it's important to remember, this is dynamic. Every time as you're using the software, as you're using the operations, these values or these options are going to change in this prediction node. Just to clarify my point about the prediction node not being available when you first start, in this case, if I launch this rotary deburring, you see I must have used rotary deburring already since I've installed this. Let's try to find something. I don't think I did any blade milling operations. Let's go ahead and pick one of these. And you'll see there is no prediction because I have not used this operation yet. You can go ahead and always clear out these settings, those kind of learned features. Again, it's going to be in your kind of local app data folder. It gets buried in there. But you see I have this note here in this presentation. So if this is something that you think you might want, all these presentations will be made available at a later point in time, and you'll be able to keep this for your record. All right, my virtual machine. So my virtual machine is taking an existing product, which is for Cinemeric controls, so Siemens machine controls. There's a product called Sinutrain, which is essentially an offline virtual controller of the machine. And it's taking that and embedding kind of this strategy inside of SECAM Pro. So this is really taking machine simulation to the next level. We're really running the simulation as if it were being driven by a machine control, and specifically your machine control. So when you have your machine kit configured through this VNCK option, this virtual numeric control, you're actually taking the archive file out of your machine tool, so you're getting all of your parameters, tool data, offsets, things like that, and running the simulation using all of that data, not just what's inside of Cam Pro itself. So if there was any differentiators between software, your digital version and your physical version, this really closes a lot of those gaps and takes things to the next level of accuracy, to really understand what's happening in the physical world on your machine tool. So there's some different licensing requirements, and you have to have a specific machine tool kit. So if this is something of interest, come and talk to us. We can help you understand how this works. But what's really unique is you'll be running this simulation instead of just doing a machine code-based simulation. It will still be a machine code-based simulation, but it's running it through your Siemens Control HMI. So you'll get an additional window that populates and shows the machine control. You can toggle through all of your offset data, tool data, different machine pages, overrides, all these things that you can do on the real machine tool, on the control. you can do here in the digital world. So really exciting new stuff that's coming into play here. Again, this is unique to Siemens controls because we have the ability to work on both sides of the aisle there, the cam offline side and on the motion control side. So it's good at great integration there. All right, we have some new tool type holders. So prime tools have been around for a while now, and NX has supported them. But we didn't necessarily have parametric turning tool holders for prime tools. And that's been the one of the additions here. So now we can really accurately go through and check for gouges, collisions, things of that nature with parametric tool assemblies inside of Cam Pro. We also have a new face turn operation. It's really simplified. It's very pragmatic. And really sets a bunch of attributes automatically. You know, cut angle, depth of cut, cut regions, things like that. And so there's only a couple options that you really need to set. Do you want to cut towards the center line or away from the center line? That's like the kind of the big question in facing on a lathe. So we'll take a look at this here in a minute, because the next slide here, displaying and generating tool paths automatically, is another new feature that works in alternating operations, and it also works in some planar milling operations. So this is a new strategy that as you make changes in your operation dialog, so say you change your depth of cut, you immediately see the update in the tool path, kind of in real time there. So the tool path is kind of always generating, and each time you're changing a parameter, it's updating that tool path right away. So let's go ahead and take a look at this. Now, let's jump back to this lathe part we have. And I'm going to go ahead and just move that operation to my unused group. And if I go ahead and create a new operation, let's come down to our turning operations. And I'm going to use the new face turn operation. And just specify some of the basic information that we need. And we can see that if we go ahead and let's display our tool path, you'll see that before I even generated anything, I received a tool path. Now I might need to come in here and change some different settings that are normal. Maybe in this case, I want to reorient my holder. Let's go ahead and set this to 90 degrees, and we're going to flip this around the holder. And you can see as I'm making these changes, my toolpath is updating. Let's jump back to our main page and say, okay, if we want to go from a 4mm depth of cut back to a 2mm depth of cut, we're constantly updating that toolpath at all times. So really cool in the fact that you're getting that real-time update as you're making your changes. There you can see I started engaging at the center and feeding away, and my toolpath is updating as we go. So notice in the operation, our generate button has kind of been replaced with a pull down. So we can choose just to generate, or we can have the automatic generate, which is the default option. So that means anytime you make changes, you're going to continue to see that toolpath update as you go. I mentioned milling, so some of the planar mill operations have this functionality as well. If we go into a planar profile operation, you'll see that we have that same behavior with the being able to select generate versus automatic generate. So this is a thing that you can start looking for. Just if this action button here has a pull down, then it has the ability to do the automatic generate. And the last point that I'm going to talk about is just an enhancement for an IPW enhancement for turning of threads. Last release, we were given some new threading tools and new threading operations. And now our IPW is able to utilize that data, and you'll actually see a threaded feature in your IPW as opposed to just a cylindrical feature formed on that IPW. So this is great. You can actually go in and use that IPW geometry for your needs. I've seen customers go in and do things like probing to check, working with large threads and actually checking their geometry on the machine tool. They can now use this geometry to program their probing operations to check this geometry. So really interesting things that are coming out. All right, with that, again, I hope you enjoyed seeing what's new in Cam Pro, and I hope you're enjoying your whole day here with us at Solid Edge University. Take care, everyone. Hello, everyone. Welcome back here at Solid Edge University. And this session is going to cover hidden gems in Cam for Solid Edge Cam Pro. We have a fairly light agenda in that we only have one point. But what we really want to do here is go ahead and do an end-to-end programming overview, just to really capture the workflow from being in Solid Edge, using the tools to go ahead and port over to Solid Edge Cam Pro, and utilize some of the latest, greatest functionality in the software to go ahead and program your part. And maybe we'll even look at using PostHub to go ahead and download interactively inside of Cam Pro a machine tool and post processor. All right, so while we only have one item here, it's going to be a lot to do during this session, so we're going to go ahead and get rolling right away. All right, so here inside of, let's jump to Solid Edge, not Solid Edge Cam Pro. Here inside of Solid Edge, I already have a simple part and a vise set up. So nothing too complex here for our example. The great thing about this combination of Solid Edge and Solid Edge Cam Pro is we can have a few different workflows. We can set up our manufacturing environments in terms of work holding, fixturing. All that stuff can be done inside of Solid Edge, or it can be done inside of Cam Pro. It's really your preference. In this case, I already went ahead and set up the part and the fixturing, and I'm going to go ahead and bring this right over to Cam Pro. So here from our Tools menu on the resource or on the ribbon bar, I can choose our Solid Edge Cam Pro icon, and that's going to route us right over to SE Cam Pro 2023. And we can see that we have our same part that existed in Solid Edge now available and open here inside of Cam Pro. All right, so I'm going to use this as my setup file. So I can just go ahead and in this case, I'll just jump right into manufacturing. And we can configure our manufacturing environment. All right, so in our geometry navigator, this is the typical workflow that I go through. I've brought my part over. I want to specify all my geometries. This is what I'm going to be really using throughout the programming process. I need to specify, what is my part? What is my blank stock? What is my work holding? I want to specify all those things. I'm going to go ahead and just edit the workpiece, and again specify our part. So this is the design part that maybe I've gotten from my engineering or from engineering department or from my customer. I'll specify what blank stock I'm going to use. A number of different ways to do this, but I'll just use our bounding block option. And I'll add a little extra height to this block. So we have, essentially our block is to size on all on the perimeter. We just have 5 extra millimeters of material on the top face. And then I'll also specify my check geometry as all my fixturing. So I'll just grab those components. And that way NX will, or sorry, Cam Pro will go ahead and identify that I don't ever want to cut into that check geometry. So this can be used for fixturing. You can also create additional geometry in order to avoid certain areas while you're machining. All right, so I'm going to go ahead and start laying out some tool paths. Again, I have my basic setup created here. Maybe I would want to go through and do something like specify my MCS location. In this case, I'll say, yeah, maybe I want to specify my MCS as the center of my stock, but right on the finished face of the part. So that's what I'm doing here, using my on part box. It's going to find the finish of my part profile. So in this terms, in the X and Y location, and it's going to place the Z on the finish face. So essentially, on the machine tool, we would likely probe or indicate if you're a little bit old school yet. And then pick up that surface, touch off the top surface of the stock, and drop down that 5 millimeters of the extra stock we had. I'll go ahead and specify that we're also going to use fixture 1, and we'll see. I'm not sure what machine tool we're going to use yet. I'll have to think about that as we're working. We have a few different machines that we could put this particular job on. All right, so there we have our geometry setup, and maybe we need to create some tooling. So I'm going to create some tools right from my library, and I'll start with just searching for a non-indexable end mill. Maybe 16 millimeters. Let's see if that's going to be appropriate for us. Let's see, I can display our tool there. Yeah, that ought to get the job done. What's our other option? Yeah, about the same. So I'll use this second tool. So that'll be good for now. We have one tool. I'll likely have to add another tool or two, depending on what we want to end up doing with this part. But that's good enough for me to start. All right, so looking at this part, I will probably go ahead and just rough out this kind of open pocket on the right-hand side of my part. I'll go ahead and create my operation, and I'll use my select from my mill contour operation types that I want to use the new 3D adaptive roughing operation. So again, if you were in the What's New session, this is a new enhanced operation. We used to have adaptive roughing. Now this is called 3D adaptive roughing. It's just a operation that's been redesigned from the ground up. It's quicker, more reliable than previous variants of this operation. And you'll see here, it'll be quite easy for me to go ahead and program this region. So right now, if I don't change any of the default settings, and maybe we'll do that, I'll just go ahead and generate. We'll see that we're going to get an appropriate tool path, but of course it's going to NX is going to try to rough everything that it can based on my settings. So you'll see it's cutting the top of this surface because I have top off flat faces set. It's also trying to cut at cut levels that it can see inside of this kind of radiused area. So I could turn off the top off flat faces. That will get rid of toolpath up on top. However, I'm still getting this cut area that I want to avoid. I'm going to handle that. I'm going to handle that at a later time. So what I'm going to do here is use trim boundaries. And in this case, you always have the option: do you want to trim inside or outside of a boundary? So I could specify a region and trim everything outside of it. So I could pick the region I'm cutting. But I prefer to not change the cut pattern at all or influence that. So I want to trim inside of this particular region that's on the left-hand side of my screen. And I'll use the curve method, and I'll trim inside of this region. So I'll specify a region and trim anything inside of there away. And I'll leave the plane set to automatic. And I'll start picking my curves. It's important to note when you're using the automatic plane method, the first two picks establish a plane for all the curves to lie on. So you'll see even if I pick curves that are on a different plane, they're projected up to the plane that was created essentially by the first two picks. Okay. Oh, I forgot one thing. So right now, let me go ahead and generate. You'll see we won't see much of a difference. So it trimmed away a little bit of that, but we need to compensate, essentially, if I snap, you'll see it trimmed directly to that curve. Well, I want to extend past that. So let me go ahead and just specify or edit my trim boundary. And on the individual member, this last curve here, I'll just go ahead and apply some stock. I'll do 10 millimeters, go a little bit overboard. And now when we generate, you'll see, yep, that region was ignored now. All right, so we have the right-hand side created for us, or roughed out anyhow. And I'm going to do a similar operation for this on the left side of our part, this radius surface. And maybe in this case I'll use multi-axis operation types, and I'll use our multi-axis roughing. I'll use the same tool, basic same process, but we're going to do it in a multi-axis method right now. So to do this, we specify our drive floor. So I'll just pick my cylindrical surface we have to drive from. I could create auxiliary geometry too if I had more geometry that I didn't have this geometry that lends itself nicely to a drive surface. And we'll select adaptive, 25% step over here. And if we come to our geometry tab, I'll likely want to use 3D because I want to recognize our IPWs, our in-process workpiece. So let's go ahead and generate this and take a look and see what the tool path looks like. All right, so the tool path looks good in general. However, I don't want it to touch any of these surfaces. These are, I'll go ahead and face those off later. So I want to avoid that. Okay, how do we limit our tool path? Well, right here we have our containment loops, and I can choose. Go ahead and turn off that display. I can just pick some containment loops on my part to go ahead and limit what cut area do I really want to look at here. So I'm going to contain everything inside of that tool path. All right, so that looks pretty nice. I like that. Likely I would change my IPW, or sorry, my gauge here. But for what we're doing here, not a big deal. All right, so let's take a look. We'll just do we'll display our IPW, and then using the toolpath animation, we'll go ahead and just play through here a little bit just to see what's going on. Maybe I'll turn my toolpath off. I get distracted by that. But you can see our nice adaptive toolpath strategy that we're using to rough out this pocket. And another depth. And then we see our multi-axis version of adaptive roughing here. All right, so that looks pretty nice. Let's keep working here. So next we want to face this part off. Let's go ahead and create an operation, and we'll just use our floor facing without wall. I can continue using the same tools and things like that I have used so far. Just specify our cut area. And maybe we'll change our pattern type. And we're cutting from the inside out currently. If we wanted to change that, we could go ahead and choose inward cut patterns. So start from the outside and cut inward. That's my preference, so I'll go ahead and change that. Okay, so I'm pretty happy with that facing operation. All right, so we have that few operations done. Let's go ahead and look at bringing in a machine tool to use for simulating and post-processing. So here I'll go over to my machine tab, and I'm going to browse for a machine on PostHub. So as long as you have a WebKey account, you have access to PostHub, and there's a lot of kits on here, some for free. You can filter by type here, so free kits. SMKS, which is what we're going to use here, the Smart Machine Kit solution, or custom, which custom is really you can't download anything. It's kits that Siemens partners are able to list here, so you might be able to use this to find a company that's already built a kit for your particular machine tool if it's not available through one of the other methods. But I'm going to filter by the Smart Machine Kits. This is a license-based approach that you can buy a license and then gain access to any number of kits on here. So you see Siemens has built 63 kits so far. And I think for this, what do we want to do? Do I want to use a mil-P or do I want to use our DMU65? I guess I'll use the mil-P. So I'm going to just go ahead and choose to download. Yep, we'll say we'll overwrite it. And yep, I'm going to replace the machine in my current part file. So directly from my part file, I'm able to go ahead and browse and pick out what part I want to use or what machine I want to use. I'm going to set my part mount junction. A little bit tricky to see here, even with the visibility. I can make that more translucent. That might be beneficial right now. And let's see here. I need to pick a new part mount junction as the midpoint of my vise. So I'll just say between 2 points. I'll pick that location. And now we're getting our machine tool loaded. Alright, I certainly don't need all the sheet metal and things like that, so maybe I'll expand the assembly. And we'll take a look and see. Let's go ahead and turn some of this extra geometry off. Alright, there we go. That's our machine. That's what we really want to see. That's what's important to us. Alright, so we have our machine. It looks like there's a couple different tables in this particular kit. Maybe I'll just blank what I don't need. Alright, so let's go ahead and jump right into a machine simulation. I'm going to use the machine code-based simulation, driving to the actual code that's generated for the post-processor. Now you can see that here in my execution view. And let's just make sure that everything's working the way that we expect. And I'll just go ahead and hit play here. Make sure that we're doing our tool change. Oh yeah, that all looks good. Of course, we can speed things up. Alright, so I think that's looking good. Let's take a look at some of our other settings. We haven't really looked into speeds, feeds, things like that, so I'm going to go ahead and adjust some of my speeds and feeds here. Oh, 16 millimeter end mill. I'll just populate some basic feeds for what we're doing here. We'll pretend this is aluminum. And once we have that populated, we will do a little bit more simulation. The simulation, depending on your feed rate, is going to run faster or slower. It's really based upon the speeds and feeds that you have in your simulation as to how fast the machine moves. You know, it's part of how we get all the times, and when machines are configured, we have the acceleration and deceleration rates factored in to get a really accurate simulation. All right, so here we can see our adaptive 3D adaptive roughing operation is going to cut away that first pocket. Let me go ahead and speed this up just so we can get through this. Let's see our multi-axis roughing. All right, just about finished up with that operation. All right, and you can see all those motions that you're always able to check between all your operations, the true motions that your machine tool are going to be making when you drive off of the machine code. That's really, really important when you get into 5-axis machines and mill turn machines with like a rotary B axis. Um, these become very, very crucial. All right, so we have a couple good roughing operations, facing, things like that. I'd like to do a couple more tool paths here. Let me create a new tool first. I'll create a tangent barrel mill. Everybody's excited about barrel cutters and finishing with them, and with good reason. There's a lot of time savings available to us. So SE Cam Pro does support these types of tools. I will go ahead and pull in a tool holder. Let's see. Yeah, that would be fine, I think, for what we're doing. And we'll push our tool inside a little bit. We'll be able to check our clearances later. So now we'll create our multi-axis operation to use this tangential barrel mill. I'll use a variable contour. We'll be using surface drive area method. So in this operation, I'll go ahead and specify my drive area. I'll pick these surfaces and specify our cut direction. I'll leave zigzag, that's fine. Let's just do 20 step overs for now, for demo purposes. So what's important here? Tool axis. These tools, these barrel tools, typically have a range of what angle they can run at, specified by the manufacturer. So in this operation, we'll go ahead and specify an angle that we want to maintain, a tilt angle. So for us, that'll be 15 degrees. So with that specified, let's go ahead and generate our toolpath. All right, let's go ahead and run a machine simulation on this operation. This is one of the big benefits of having the integrated simulation inside of your CAM system, is that you can continually just bounce back and forth between simulation and programming. So you can simulate as you're working, and you don't go through the whole programming process and then realize things. You run out of travel, you run out of this or that. Tool doesn't reach, things along those lines. And then you have to reinvent the wheel, and you've already had a lot of time and effort into your process. So that's great. So let's take a look at this. You can see how well the barrel cutter is going to work here, cutting down this wall. All right, so let's go ahead and look at maybe cutting this blend, finishing this blend. And we'll be able to use that same tool. So let's go ahead and grab a contour profile operation. Again, using our tangent barrel cutter. And inside of contour profile, let's go ahead and just specify our floor geometry. And SE Cam Pro has this automatic walls option checked by default. So when I display, we can see what our wall geometry, so it's the blends and the vertical walls here. And what we want to do, contour profiles is intended for swarfing geometry. But in this case, I want to apply some tilt, and I'll probably just start with 45 degrees and see how that looks in simulation, because I want to use the nose of the tool to cut this blend. So let's go ahead and generate that. All right, that looks good. Again, let's do machine simulation just to check this out. Oh, pick my operation. It's gonna, anytime you pick operations or go into simulation here with machine code-based simulation, it's running the post processor to get the code for that particular operation. Slow this down, get our tool, and you can see how we're tilting. And let's see if we have enough clearance along with our holder. I think we're going to run into a problem. And my tool checks on there. Let's play this backwards a little bit. All right, now let's play that forward. All right, now you can see how we get the alert that we're colliding with our tool holder. All right, so let's go ahead and resolve this. So I just want to show another cool feature inside of SE Cam Pro. Instead of going around and trying to look at controlling my tool axis or things like that, I want to use a function that we have called tilt tool axis. And now what tilt tool axis is doing is it's going to look at some collision data in this avoidance method, tilt and retract, or purely retract. But what's going to do is modify our tool vector throughout our toolpath to maintain our shank and tool holder clearances. So all I'm going to do, just by saying OK there, it modified my toolpath. Let me pull out my ribbon bar, a resource bar, and you can see my toolpath has been edited by using that tilt tool axis option. Now, when we go and simulate the machine, we can go ahead and play this through. Come back in here. And now we're getting up towards that wall. And look, our rotary starting earlier to avoid those collisions. Let me come around to the other side here. And we can see that we're not touching those walls at all. So a really quick way to go ahead and control and modify some of your tool vectors. I really like that option. All right, so there we've gone through. We've done some 3D adaptive roughing, multi-axis, floor facing. Variable contour was using the barrel cutter to finish this geometry. And then we went ahead and cut that blend and showed a little bit about the tilt tool axis. So of course at this point in time, since we installed our machine kit, when we go to post-process, you'll see that our MIL-P post-processor is available to us, that we could go ahead and post just through any normal environment. But when you have your machine kit loaded, you will always have the appropriate post for that machine. All right, well, I hope everybody found this session useful and beneficial to check out and see kind of just a beginning to end workflow of going through a process. And if you have any questions, as always, feel free to reach out to me or the rest of the Swoosh team, and we will be here to answer any questions and help you along with your processes. Take care.